Hello, good afternoon. Thanks for joining Microsoft Azure Power Lunch. My name is Ranga Vadlamudi. I work for Azure IoT engineering team, and today I'm going to talk about how to enable edge intelligence with Azure IoT Edge. So the agenda for today's session is basically I'm going to talk about the concepts of an Azure IoT Edge, then the runtime architecture. I'm going to do a couple of demos using Linux and Windows machines, and then question and answers. So before I start off with the Edge, one thing I wanted to talk about is what are the Microsoft Azure IoT offerings. So basically, we make it easier for you to build secure, scalable solutions from device to cloud. For that, we have a couple of offerings. Basically, the Azure IoT Suite, which are pre-configured solutions. And the common scenarios are remote monitoring, predictive maintenance, and connected factory. We came out with a new SaaS offering this week called IoT Central. So basically, an IoT Central helps you to accelerate your IoT deployments. Microsoft manages pretty much the solution. You bring your devices connect to IoT Central, and you get visualization. You can apply rules around the data which is coming in, and pretty much the telemetry is stored and managed by Microsoft, and the overall deployment of your solution becomes easy. One of the questions which came out from the chat window is, does IoT Central replace an IoT Hub? So what IoT Central does is we basically manage the solution. So under the hood, IoT Hub, etc., the storage, visualization, pretty much everything is managed by Microsoft. So it's not exposed for you as a user to manage each individual component. So that's the biggest difference you'll see between an IoT Hub versus Central. The other offerings include we help you to easily provision and manage your devices at scale. And for that, we have something called a device provisioning service. So the device provisioning service helps you. It's a zero-touch device management solution, and it's fully managed and at scale, so you can manage thousands of devices. So what it does for you is whenever a device is shipped at the manufacturer, you don't have to put in the information of an IoT hub, etc. So basically, when the device wakes up, it connects with the device provisioning system to find its home of where its IoT hub is. So this really helps you to manage your device much easily. And whenever the device is manufactured and by the time it gets shipped and deployed, things can change, like companies can merge, there could be acquisitions, etc. Or you could have a multi-tiered solution on the cloud. So you don't have to really know the IoT hub information at the manufacturing time. It will find its home through the device provisioning system or the device provisioning service when the device wakes up. And the Azure IoT Hub offering, we have had it for a while. It helps you with two-way communication, device to cloud, cloud to device, and you can, at scale, connect millions of devices and send trillions of messages to the cloud. And also we have offerings around once you connect your devices, send your data into the cloud, then how do you find insights? And for this, we basically have time series insights, which helps you analyze the time series data which is coming in, the real-time data at scale, and it's a fully managed offering. So you get visualization, you can query your data, etc., and then you can create your dashboards using TSI. And one of the new offerings which went public preview is Azure IoT Edge, where you can actually securely distribute your intelligence locally. So basically, whatever intelligence you have created on the cloud, it could be streaming analytics, you could use functions, machine learning, AI, etc. The same bits can be brought down onto the edge and run at scale. So these are the overall offerings Microsoft IoT has. And today what we are going to do is we are going to drill down into what Azure IoT Edge offering is and do a few demos around it. So IoT in the cloud and on the edge. We have had IoT services in the cloud for a while. So some of them are like remote monitoring and management. We have pre-configured solution. We have platform solutions which can scale from message buses all the way to capture the telemetry data, store it into the cloud, visualize through different products like Power BI, time series insights, etc. So the cloud offerings, what it did for us was we could get infinite compute and also infinite storage. And it would help us with the intelligence on the data which is being captured through training the machine learning models on the cloud by using the data which is being collected, and also other advanced AI tools like image processing, face recognition, etc., etc. So once we had this services being used by our customers, we got some requests from customers which they wanted to make sure that some of these solutions could be run on the edge. And the reason for that is they wanted low latency tight control loops, basically which requires real-time responses. Also, the protocol translations like standard protocols like AMQP, HTTP, MQTT. These are offered through our IoT hub, but then if there are any protocols which are like Modbus, PACnet, etc., which need translation before it gets to the IoT hub. On the cloud solutions, we used to run those protocol translations on the cloud. We can bring that onto the edge. And also any data normalization which you need, those can be run using our Azure IoT Edge. Another request which came in is the reason for the edge is some of our customers need privacy of data. They don't want to put everything on the cloud as far as what they want to keep it at the location, and also for protection of IP. So due to these requests, what Microsoft has done is basically they're giving you two offerings. One is run your IoT offerings on the cloud for scale, infinite on the compute and storage, as well as apply intelligence, but then use the same bits and try to bring it down onto the edge and reuse the same capabilities where it could apply for one manufacturing plant, etc., on the edge. So why Azure IoT Edge, right? Here is an example where there is a remote machine which is running. It's a sucker rod pump, and it's basically far away remote location with little or no connectivity, and also no human supervision most of the time. So these machines run constantly. They run 24/7, and you have to basically take into consideration there could be changing conditions, temperature, pressure, weather, etc., etc. So what Schneider Electric, one of our customers, did was they would run SCADA systems on in the remote location and collect the data and bring it back to their data centers and upload it to the cloud and run machine learning models on it at scale and come and basically train the models and score them and detect anomalies, etc., so that they can come back to these locations and do maintenance. So if you look at this slide, basically what's going on here is there's oil being pumped, right? As the pump goes up on the y-axis, you see that the pressure goes up, and on the x-axis is the location of where the pump is, right? So this is a normal condition where from the surface of where you think the pump is, as well as how much fluid is it's being extracted, and downhole, it's all in sync. So that means the pump is running fine, everything is going well. So these data points are captured, which are called as dynacards. So you could have tons of these dynacards which will be collected at certain points, and in a cloud situation or in a remote monitoring situation, a person goes in, collects this data, or they'll collect this and send it via when the connectivity is up for them, which is not available all the time. And once the data is collected, it's brought into the cloud, and algorithms are run, trained, and the anomalies are detected, and somebody goes back and make sure that either they are doing a maintenance, or they're slowing down the pump, or they're shutting down the pump. So this is a tedious process. So for this, what is your alternative solution, right? So in a current scenario, on a well site, there's an RTU where data is collected, and through Modbus, the data is sent into an IoT hub. And from there, intelligence is applied, models are trained, scored, anomalies are detected. But once we bring down the an edge-like device, then you can actually run the same bits on the edge. So here what's happening is data is collected from the Modbus, and there is a module which runs, which does it's basically doing data transformation so that the data can be fed into an Azure ML model, which it understands. And once this is mostly for scoring on the edge, right? You do training on the cloud, bring it down, and it's for scoring. And as it's scoring, it could find an anomaly, and when it finds an anomaly, a command can be sent back for either to slow down the pump or to actually shut down the pump. And another path can be taken where data can be sent up to the cloud for alerting, as well as the same data can be fed into like a reinforcement learning for the machine learning model, so that it can keep learning from the data it's getting. And then the analytics which are already running, you can actually hook in your machine learning models into the analytics, so that an operator on the edge can actually look at these anomalies and take some manual actions if needed. So that's the benefit of having both a cloud solution and being able to run the same bits on the edge to help with scenarios like a remote locations where it's very expensive to send a person, or to be able to go and collect the data and bring it back to the cloud. Because if you're actually taking that time to bring back to the cloud, the damage could have already been done because you have not seen the anomaly happen in real time. So the next thing what we're going to do is we're going to talk about the design principles of an IoT edge scenario, right? The first thing is security. So what Microsoft has done is we have focused on security. So for an IoT edge device, we want to make sure that the connection is secure into the cloud, as well as if there are any firmware updates, software updates, etc., which can happen remotely, and how we collect the telemetry data. So we want to make sure that the monitoring of the device happens very securely. And also this device can be in a physical location, in a location where somebody can get a physical access to that device, as well as they can get a long time to work with on that device to do some damage. So I'll go over some of the security principles in another slide, but overall Microsoft is recommending a framework on how do you run edge devices securely. Then the next design principle is we wanted to make sure that these devices are managed from the cloud. So we have a rich management solutions on the cloud for the edge. And what we do is we make sure that you're able to deploy modules onto the edge managed through the cloud. And it's cross-platform, so we support both Windows and Linux, and various versions of Linux are supported. Portable, we make sure that it enables dev test with edge workloads, and also with your ML models and your custom modules which you develop. It goes through your very similar CI/CD pipeline. So basically, you can build these modules and put them through continuous integration, continuous deployment. So every version of the package you create, you can push it down onto the edge and keep it up to date. And also extensible. So we want to make sure that the intelligent solutions you're creating on the cloud, you can actually seamlessly deploy them. You can create third-party modules and also the AI from Microsoft, which could support whatever you're doing on the cloud. So concepts-wise, we'll talk about what a module is, and then go into the various aspects of a runtime architecture of an IoT edge device. So the first thing is a module image. So what you do is you basically create a module, and then you create an image of it. So it's containing software that defines a module, and also the module lives in the cloud. Then there is a module instance. The module instance is basically a specific unit of computation running on an edge device. So every edge device, if it has a running module, that actually is an instance of that module image. And then we have the module identity. Pretty much it's a piece of information including security credentials. It's stored in the IoT hub, and it's associated with that module instance. And we have module twin, like a device twin. So it's a metadata. It's a JSON document stored in IoT hub that it contains the state information of the module instance. So it's basically the configurations, conditions, etc., and it's associated to an instance of that image. So we'll talk about IoT Edge runtime. So what you do is you basically deploy the runtime on the IoT Edge device, and you do updates through your CI/CD pipeline we talked about in the previous slide, where you create images, you version them, and you push new versioning onto your runtime so that they can run on your edge. Also, we make sure that all the module maintains the security standards as far as if a new module comes down, checksums are applied, that it's made sure that nothing is tampered by the time it's deployed. All those are taken care through the runtime. And also, the runtime makes sure that the modules are always running. So the runtime has two pieces to it. One is the Edge hub, and another one is the Edge agent. So the Edge agent makes sure that the modules are always running. And also, the runtime reports module health to the cloud for remote monitoring. So overall, runtime helps you with facilitating communication between downstream leaf devices, which are connected to the IoT Edge device. So in this scenario, what happens is there's the Edge connecting to the IoT hub, but there are leaf devices connecting to the Edge, and there is one connection. So multiplexing happens here, where the runtime is making sure there's one connection into the IoT hub. And also, the runtime helps you facilitate communication between the modules. So that's where the IoT hub comes into picture. The Edge hub. The Edge hub helps you how these modules communicate between each other. What you can do is you can actually create a pipeline. Let's say there are 3 modules sitting on the runtime and all 3 have to communicate in sequence. You create a pipeline where through routes, and you basically define those routes on how these modules communicate with each other. And also, the hub makes sure the Edge hub is the one which is helping you with communicating between the Edge device and the cloud. So as a summary, the runtime has 2 components. One is the Edge hub and the other one is the Edge agent. Edge hub is helping you communicate between leaf devices and the Edge runtime, as well as it's communicating with the IoT hub. And the Edge hub helps you, the modules communicate with each other. And the Edge agent make sure that these modules are always running, and if there are any updates pushed, it makes sure that the updates are happening on the edge. So the IoT Edge in action, I'll go through how this happens. So basically, an edge device is provisioned with the right agents for your scenario, and then you basically have to select an edge node on where you want to basically deploy these modules. Then you define your module of the edge node through a device twin. So you could run like 5 modules or 1 module, etc., which you want to bring down to the edge. So you define that through your device twin. And on the right-hand side, what you see is you can actually create these modules. So the modules are basically container-based. They are Docker container-based modules. And we support currently Azure Functions, Azure Stream Analytics, and Azure Machine Learning. Along with your own code, you can create custom modules. So whatever you create, Azure Functions, which you have been working with on the cloud, you can create the same things for the edge and bring them down as container images to be run on the IoT Edge. And once you bring down the containers, container modules, they are basically deployed into the Edge runtime, and each module will have its own module twin, which is the metadata of the module, and the module twin represents an instance of that module image. And then you connect your Edge Hub, basically your devices, your leaf devices, etc., to the Edge runtime, and this happens through the Edge Hub. So moving on to security, some of the principles and goals of what we did with security is we wanted to make sure that it's cross-platform, so we support Linux and Windows and multiple architectures of the OS, and as well as multiple versions of like a Linux. And then we made sure that we use standard protocols. The next thing we did was we wanted to make sure that we isolate the security aspects and the hardware aspects from an app developer who can actually focus on developing the modules which will run on IoT Edge. And also we made sure the technology is available as far as what is available on the cloud. You can run similar the bits which are running on the cloud on the edge, like functions, stream analytics, and ML, like we talked about before. So if you look at this slide right now, what I'm going to talk about is what is the framework we have created, right, from bottom up. If you look at hardware root of trust, so we basically that's the lowest layer of hardware, and we based it on the root of trust or the hardware root of trust, which is called the trust anchor. Essentially, it is the hardware-based private key stored in the hardware root of trust, and we make sure that it's immutable and undiscoverable. So it's basically stored in the firmware itself, and we are working with the firmware vendors, the silicon vendors, to make sure that the hardware root of trust is provided as part of the security framework. Then if you move up into the secure boot and updates, when a device is booted, we should make sure that it should be attested, and whether the right firmware it's running on the right firmware still. And also you securely, if you're updating the OS itself, we make sure that secure updates are happening on the IoT Edge device. And then if you go up all the way, right, we want to make sure that the application execution is happening as far as how does this edge device connect to leaf devices? How does it connect to an IoT hub? So one of the questions in the chat window which came out was how is security taken care, right, overall, and also is TLS used? So if you look at our current offering, an IoT Edge runtime, when we use the script to actually deploy the runtime and also run the setup to basically bring down the device twin, what we do is a certificate is created for the Edge Hub, and this certificate is used by the Edge Hub to accept incoming TLS connections from leaf devices. And the current offering helps you, the IoT Edge device, connect to IoT Hub through a SAS token. So that's the current offering we have as far as how do leaf devices connect to our IoT Edge, and how does IoT Edge connect into the IoT Hub. So the hardware for IoT Edge, we talked about Linux and Windows supported on x64 and ARM, and we need to make sure that These are like Docker is enabled, support for containers is required for these devices. And if you look at from left to right, all the way from low capability devices, you could go to a high capability devices like gateway tier. We pretty much run Edge on almost all these devices. How do you uh, make sure that the device or the Edge runtime works here, right? So you need to make sure that the OS is Linux or Windows, and also we have some requirements like Windows, especially it's a Windows 10 has uh, creators update, and also Python 2.7.x is running, and it's Docker enabled. So IoT Edge, as far as what all we support, right? So we support stream analytics. So basically, it's what you have been running on the cloud. It's exactly the same experience. All you have to do is you now have a new capability of you should be able to run this on the edge along with on the cloud. So you can choose between a cloud and an edge when you're creating a stream analytics job. The next thing is we provide tooling with VS Code for you to be able to run functions. So the functions, whatever you create on the cloud, you can actually use the the VS Code Studio to be able to create these functions and then package them as containers. So you can package them in containers and move them to Docker Hub or Azure Container Services as images. And from there, you can push down those images as module instances onto IoT Edge device using your device twin. Then there is Azure Machine Learning. So you pretty much create your machine learning modules and push them onto the edge and run them on the edge. Developer experience, we wanted to make sure that you're able to actually have a nice experience of developing these modules using VS Code. So currently we support C# and C, Python, Java, and Node.js are coming soon. And once you build your modules, you basically can push them into container repositories like Docker Hub or Azure Container Registry. And here is the portal experience. So basically, whatever you have been using the Azure portal to be able to create IoT hubs, create other Azure IoT services, you could use the same interface to work with an edge. So what I'll do today is I'll do a couple of demos using a Linux box where I'll actually create a runtime there, deploy, set up a device twin, deploy modules and run them. And similarly, you'll see a very similar experience on Windows. So let's start here. What I've done is I've created a VM. It's a Linux VM here, pretty much so that I can use this as an edge device just to show you that the runtime can be run on Linux and how do you actually bring down modules, how do you run them, etc. Where do you start off is you go to IoT Hub. You create a IoT Hub. Right now I have one which is running. And from here, go to Explorers and find IoT Edge. And what you do is you have to start off with a device twin here. Currently, I have a few of them running, actually a few of the devices created. But the experience is what you do is you go and click on Add IoT Edge Device and give it a name. So I'll call it my Power And authentication type is a symmetric key. So if you go to the IoT Hub policies, it's a device connect policy. Basically, what you do is you make sure you're connecting with the device connect policy, and this interface helps you. Either you can auto generate the keys, or you can give your own as far as the symmetric keys are concerned. And also on the device itself, when you set up your device on an edge, you can either go in as enabled or disabled. Currently, the default is enabled, so I'm just going to go with the default. So once you save it, here you go, you have a new device. And if you go into the details, it actually gives you a connection string like any other IoT Hub experience you have used before. And it tells you what modules have been deployed, etc. Currently, there are no modules. So let me go. So since I have the device twins created, or devices created here, so let me jump into a Linux box here. So if you look at this, it's an Ubuntu machine. So what I'll start, a couple of things you need to make sure before you start is whether Docker is running. So let me check if Docker is installed here. So we have Docker here, and also there are a few modules running right now. So what I'll do is, since this is an existing device where IoT Edge has been installed and deployed, I will stop the Edge runtime. Once it's stopped, where you will start off is if you have a new machine where you want to start off with your runtime, you start here. You basically make sure that you install the runtime. And since currently my runtime is already installed, most of the requirements are already met. And when the runtime is installed, the next thing what you want to do is you want to check if your runtime is installed. So you IoT Edge CTL. If I look at the help, it gives you a few commands, so you can actually set up the runtime. This must be run before you start. The next thing is you can start a runtime, you can restart, you can stop a runtime, as well as you can check status and update any agent images, uninstall images, etc. So what I'm going to do is, first thing, I'm going to set up a device here, and so that I can connect or make sure this device has a device twin, which IoT Hub recognizes. So you run the setup command. So I got the connection string when I created the device on IoT Hub. And if you look at it, you basically, this is the connection string for the device. And it has actually installed some self-signed certificates. And you can see where the certificates are. This is where you'll find the certificates being installed. And also what it's telling me is, hey, everything looks good, your setup looks good. Now you want to use the this command to start the runtime. So I'm going to start the Edge runtime using this command. So it's telling me that the Edge runtime started, so I can check the status. So it's telling me that it's running here, right? So once it's running, now what I want to do is I want to see if how my Docker is behaving, right? So what has happened here is three things have happened. One is an IoT Edge agent module was brought down when this machine was set up for its as an Edge runtime. The second thing is an IoT Edge hub module was brought down, and also what I did was, since this is an existing IoT Edge device for me, I actually using the web portal. If I go here to my device details, I actually took an existing image from Docker Hub, and I actually installed it. So here is it's a temperature sensor. So the way you do it is you can actually add an Edge module, and when you add it, you give it a name, and then you give the image URI, which is your either your Docker Hub URI or an Azure container, a container registry. And once you give that, also what you do is you want to make sure you provide a restart policy when for the container. What happens if something happens? Do you want to always restart or never restart? What do you want to do? You basically want to give that policy. And also, when the module goes down onto the edge, how do you want the desired state? Do you want it stopped, or do you want it running when it goes there? So if you go back to the Linux box here, these are in running state right now. So there are 3 modules which came down. 2 of them automatically come down because of our runtime, and then I added a temperature sensor simulator to be installed onto the Edge device. So once the Edge is started, right, then what you can do is you can check. So I'm going to check on my temperature sensor what it's actually doing. So you can So I'm looking at the logs. It's basically sending out some JSON data. So this data is basically going into an IoT hub. So currently the data has temperature, pressure, humidity, etc., which is it's a simulated data right now. So when you connect your real devices, you connect your devices into the Edge runtime, and it'll be sent onto the cloud. And if you have many modules, you build a pipeline so that the data is passing it into multiple modules and then makes it all the way into the cloud. So what I did is, once this data is being generated and sent to the cloud, I basically created something called time series insights. So this time series insights is a PaaS service where you can actually, all the data collected into an IoT hub can be consumed by time series insights. For visualization, you can actually look at how the data is flowing. You can query into the data. So the way you hook up time series insights into the IoT hub is you create an event source. And when I created this event source, I told it to connect to the IoT Edge hub to be able to consume the data which is flowing in. And once you make that connection, then all you have to do is click on the environment. It takes you into a portal where you can actually explore your data which is flowing in. I'm going to do a very basic demo of the TSI here. It actually has a lot more features than what I'm going to show. So as the data is flowing in here, what you can do is you can split the data by device ID, and also you can split by, I just want to look at like probably machine pressure, or I can do temperature. So as the data is flowing in, you'll see real-time data coming in. So what we have done here is we have actually created an end-to-end experience. We created an IoT Edge on the or IoT Hub on the cloud, and then we created devices, and the device twin was set up and created on the edge. And once you had the runtime on the edge started, then basically the cloud manages all the modules. So the device twin actually defines what modules will go down onto the cloud, onto the edge, and the cloud pushes all those modules onto the edge. The modules come up, they are lit up, and they are alive. And one of the module was a temperature sensor, which was sending out data. We were able to basically collect them into the IoT Hub and connect TSI, which is the consumer of the data, and visualize the data here. So it's an end-to-end experience of running both cloud and an IoT Edge solution. And basically, the module which was created was managed and run on the cloud as well as on the device, so or on the edge device. So the next thing what I'm going to do is I'm going to show you a very similar experience on Windows. So on Windows, again, one thing which I want to see here is what version of Python. So I have 2.7.11. I want to make sure Docker is installed and also Docker is running. Currently there is nothing running here. So what I'm going to do is I'm actually going to go and start the runtime. So IoT Edge, I'll look at the status first. So it is stopped. If you're wondering how did this Windows end up with a device twin, right? So what I did was I created this already. If I go to the IoT Edge Hub, you will see this is my surface. Basically, it's Windows 10 with the creators update. And I created a device twin here, so it has a connection string. So I went and set up this device already. So now I'm going to start it. So if you look at it, right, you pretty much have a very similar experience working with Linux versus Windows. And if I look at the status now, so it's running. Then what I'm going to do is I'm going to look at what's running. So one of the difference you'll see between the Linux box I have and this Windows is on this device, I actually have an extra module, which is a stream analytics module. So the way I did this is if I go into the set modules, first of all, you'll have to go and create a stream analytics job. So for that, if you want to create a stream analytics job, you go and create one. And when you add this, you'll see this new experience where you actually can create one for the edge as well as one for the cloud. So I already have one running right now, or one created for the edge. So it's a very similar experience. If you have experience working with the cloud stream analytics jobs, what you do is you basically create an input. One of the difference you'll see is if you want to create an input for the edge, you give it a name, but the source, all you'll see is an IoT Edge Hub, so or an Edge Hub, right? So what it means is the input endpoint for this module will be through an IoT Edge hub, because the way we built it is modules can you can communicate with modules only through an Edge hub. The next thing what you do is you go and create an output. And the same thing here, where all you'll have for the sync is an IoT Edge or an Edge hub, right? So basically, this is an output endpoint where another module can actually become the receiver of this the sync output. The sync output of the Azure Stream Analytics. So once you have this, then you'll need a query. So what I'm doing here is I'm actually, I have a query where there's a tumbling window of 30 seconds where it's taking an average of the temperature. And if it goes more than 100, there's an alert or a reset command is sent. So this can be used in scenarios where you can actually send it all the way to the device you're trying to manage. It could be a well site, it could be that sucker rod pump, where you're telling it to either slow down or basically shut down, etc. So the Stream Analytics job is bringing that intelligence onto the cloud, sorry, onto the edge. So once you have this job, then what you do is you go back to the IoT Edge or the IoT Hub, and I'll go select my Surface device and then look at the modules. So I set one currently. I have one which is running. The way you do it is you select, you want to import a Edge module or attach this module into the into your device twin. So you basically go and find that Edge job. It could be, you could have many running. Right now, since I have only one Edge job running, I go select that. And then also you have your storage account where the ASA for the IoT Edge uses to manage the job or to put in information, etc. of the job. So once you have that, what you'll do is you'll actually create routes. So here, some of the routes I have is, if you look at the telemetry data from the temperature sensor, I'm directly sending it upstream. Also, if there are any alerts, so I built a pipeline of how the messages are communicated, right? Also, the alerts from this module, which I just created, the ASA module, that's also going upstream. Another thing which is happening is the module's output of the ASA is actually going into as input into a temperature sensor. So if you, at this point, what it'll do is it'll basically go invoke a method where it would probably go reset the temperature. And then the a third thing which is happening is from the temperature sensor, we are taking every the data which is being generated by the simulator, and we are sending it into an Azure Stream Analytics module. So what happens is it basically captures that data and it applies that query we wrote, which is a tumbling window, which is actually capturing the temperature, whether for 30 seconds, if the average is more than 100 degrees, it probably issues a reset, right? So once this routes are set up, then you pretty much go next. So what you do is now you have this device twin. So if you look at this, what it has is it has all these modules. So it has an edge agent. So basically the edge agent will be installed onto the edge device. Also the edge hub. So these are two default modules which will be pushed down. Along with it, there is a temperature sensor simulator module, which is a C# module, and also an ASA module, which is our Azure Stream Analytics module. So there are 4 modules which will be pushed down, and here is the routes and how do you want the data to flow between the modules, as well as how you want the data to flow into the IoT hub. So once you have that, you submit, then you pretty much will end up with this. So you'll see that these 4 modules are running, and if you come back into the device, which is my Windows device, you'll actually have the same thing here. So at this point, what's happening is basically the device twin is actually created on the edge device, as well as the module twin. And all the modules which are part of the device twin are brought down onto the edge node. So if I look at this right now, so I have these, you'll see the same experience. So if I go to look at you'll see the same data which is flowing in. Basically, it's generating the temperature data, humidity data, etc., onto the. It's sending the data into the cloud. So the 4 routes which we created, one of them is directly push the data into the cloud. Another thing what you can see is if you go back to the these are the modules. So I'll take this module name of the ASA, and I will try to look at the logs of the ASA. So at this point, if you look at it, there is data flowing into the ASA where it's basically applying the data which is flowing in into the query, where it's doing it's applying the tumbling window to make sure that if the average temperature goes above certain point, you actually send a reset command. So this is an end-to-end of how you can actually create. How do you start off with making a machine or an edge device, right? Like a real edge device, you install the runtime, and then you set up your device twin. And once you are able to connect to the IoT hub, cloud will manage based on your device twin what modules have to be brought down onto the edge, and also the routes will help you with how the data is communicated between the modules as well as to the cloud. And we have seen an overall experience of how the data is collected in the IoT hub, and TSI becomes a consumer. You can create it however you want. If you want to push it into storage, you can actually stand up a Stream Analytics on the cloud and send data into Data Lake, Cosmos DB. You can create a real-time streaming job where the data is going into Power BI. So a lot of plug and play experiences, and you can actually send data into a machine learning model which has been trained and used for scoring on the cloud, as well as the same module can be brought down and deployed as a module on Edge. So going back to the presentation, so what I would suggest is you basically pick your machine. It could be Windows, it could be Linux, it could be a device itself, a Raspberry Pi, and just try it out. And there are step-by-step tutorials. If you go to our website, here it is, and get started. Basically, if you want to pick your Windows device or if you want to pick your Linux device, just go for it. And I think the more you try it out and use Azure to create your device twins, create your module twins, and push modules onto the edge, create your custom modules, use VS Code. And we have enough tutorials out there for you to be able to go run with it. Thank you for attending this session. I hope it was useful, and we'll have a few of these on IoT on our other services as we it's a great forum for us as far as the Power Lunch is concerned, and thanks for attending.